Dear students, in this video we will deal with the second colligative property, that is elevation of boiling point, which is also called as ebullioscopy. Now let's see first what is the boiling point of a liquid. The temperature at which the equilibrium vapor pressure of a liquid becomes equal to that of the atmospheric pressure is called the boiling point of the liquid, and the increase in the boiling point of a solvent on addition of a solute to it is called the elevation of boiling point फॉर दैट सॉल्वेंट. इसका मतलब बॉइलिंग पॉइंट वो टेम्परेचर होता है जिसपे वेपर प्रेशर लिक्विड का एटमॉस्फेरिक प्रेशर के बराबर हो जाता है, और अगर आप उसमें कोई सॉल्यूट ऐड कर देते हैं तो जो इंक्रीज होता है बॉइलिंग पॉइंट के सॉल्वेंट में उसको एलिवेशन ऑफ बॉइलिंग पॉइंट कहा जाता है. नेक्स्ट यू कैन सी हियर अ ग्राफ हैज बीन प्लॉटेड बिटवीन वेपर प्रेशर एंड temperature in the Kelvin. Here P naught is the vapor pressure of the pure solvent at its boiling point TB. P1 is the vapor pressure of solution 1 at temperature TB, and P2 is the vapor pressure of the solution 2 at temperature TB. And these are the graphs showing here. Now if we consider here this BC line, BD and CE. If we consider this as straight lines, then you can consider this triangle ABD and ACE as the similar triangles, and with the law of similarity you can write AB upon AC is equal to AD upon AE, as I have written here, because we consider these two triangles as similar. Now what is AB? You can write the value here, that is T1 minus TB, and AC is T2 minus TB. And similarly here AD is equal to P naught minus P1 and AE is equal to P naught minus P2. So that values I have already substituted, and I have already told you about what is P1, P naught and P2. Now this equation can also be written as T1 minus TB can be written as del T1, that is change in temperature, 1 divided by change in temperature in solution T2, and this is the change in vapor pressure of solution 1 and solution 2. So this is considered as equation 2. Now here this TB1 is the elevation in the boiling point for solution 1. This is elevation boiling point for solution 2. This is lowering in vapor pressure for solution 1, and this is lowering in solution for 2 for lowering in vapor pressure for solution 2. And from this equation you can clearly see that elevation in boiling point is directly proportional to the lowering in vapor pressure. That is equation number 3. Now as we have already discussed in the previous video, according to Raoult's law for dilute solution, this was the formula: P naught minus P upon P naught is equal to small w capital M and capital W M dash, where this is the weight of solute, weight of solvent, this is molar mass of solute, and this is molar mass of solvent. Now here we can replace this with del P, and this is P naught, similar fraction. Now if you have to find the del P, you can put this P naught here, multiply it, and you will get the del P. Now since P naught M is constant for a particular solvent, because P naught is constant, that is the vapor pressure of the solvent in the pure state, and M is the molecular weight of the or molar mass of the solvent, that is constant. So we can also write that above equation as lowering in vapor pressure is directly proportional to small w upon capital W into M dash. Now from third and fourth equation you can also write del TB is directly proportional to this, because both are equal. Now if weight is 1 kg, then this expression is equal to the molality of solution. And what is molality? The weight of the solute dissolved per kg of the solvent. So this can be also referred as molality. So we can write from above del TB is directly proportional to molality. And if you will remove this proportionality, you will get an equal sign and a constant called as molar elevation constant or ebullioscopic constant, which is defined as the elevation of boiling point produced on dissolving 1 mole of a substance in 1000 kg of the solvent. Unit of Kb may be Kelvin per molal or degree Celsius per molal or Kelvin kg per mole. Now this is the expression for elevation in boiling point, mR TB square upon 1000 into del HB, where TB is the boiling point of the solvent. This is molar enthalpy of vaporization of the solvent. This is a constant, gas constant, and this is the molar mass of the solvent. Now in this expression, another replacement is by LV, which is the latent heat of vaporization per gram of the solvent, that is del HV upon M, and we will replace this in this expression and you will get Kb as RTB square upon 1000 LV. So depending on the value is given, we will use the different formulas. Now from these derivations, what we have generalized, that the elevation in the boiling point of solution is directly proportional to the molality of the solution. अगर solutions जो हैं वो equimolar हैं और different solutes उसमें dissolved हैं, तो elevation in boiling point हमेशा same होगा. अब क्योंकि ये मोलालिटी का फॉर्मूला है, इसको आप इस 6th इक्वेशन में हम सब्सटीट्यूट करेंगे, तो यू विल गेट डेल टी बी इज इक्वल टू के बी इंटू मोलालिटी. यहाँ पे हमने वैल्यू सब्सटीट्यूट करी, और इसमें इफ यू वांट टू टेक आउट द मॉलिक्यूलर वेट ऑफ द सॉल्वेंट, देन वी कैन accordingly adjust the formula by cross multiplying it. And the 7th equation is valid only for a non-electrolytic solute. Now let's see some of the numericals related to it. Now students, let's solve few numericals. Question number 1 here is a solution containing 12.5 gram of a non-electrolytic substances, 175 gram of water gave boiling point elevation of 0.70 Kelvin. Calculate the molar mass of the substance, and the boiling point of the water has been given as 0.52. So you have to calculate the molar mass of the substance. So I have already put the formula, that is 1000 into Kb into W upon W dash into Tb. That is equal to 1000 into Kb is given as 0.52 boiling point for water into weight of the solute, that is 12.5 gram already given in the question, divided by weight of the solvent, that is 175 gram, multiplied by elevation in the boiling point, that is been given as 0.70 Kelvin. So we'll write here 0.70. That will be equal to, if you'll solve, we will give you 53.06 gram per mole. So this is the molar mass of the substance in the following question. Next question is a solution of 3.795 gram of sulfur in 100 gram of carbon disulfide with boiling point given and latent heat of vaporization is given, boils at 46.66 degrees Celsius. What is the formula of the sulfur molecule in the solution? So firstly we have to calculate the Kb, that is boiling point. For that I have already written the formula, that is ebullioscopic constant Kb, mR Tb square upon 1000 into del Hb. So here the molecular weight of the carbon disulfide will be, carbon disulfide is CS2, carbon is 12 and 32 2 are 64. If you will add, you will get it as 76 into gas constant is 1.76 into 1.987 into Tb square, that is the boiling point. You have to convert it into Kelvin, that is 46.3 degrees Celsius is there. You have to add 273 and you will get it as 319.3 whole square divided by 1000 into latent heat of vaporization has been given as 6400 calorie per mole. So we will put here 6400. Now if you will solve it, you will get it as 2.41. That is the value of Kb. Now you have to find the formula of the sulfur molecule, but for that firstly we want the molecular weight of the solute. So again the same formula that I have used in numerical 1, that we will use 1000 into Kb, that we have taken out is 2.41 into weight of the solute is 3.795, that has been given in the question. This is the weight of the solute, divided by weight of the solvent, that is 100 into elevation in boiling point. So for that you have to subtract 46.66 minus 46.30. So that will come out to be 0.36, and that is equal to, if you convert it into Kelvin, again you will take out, same answer will come, and if you will solve, you will get it here as 254.05. So that is the molar mass of the solute. Now as the atomic weight of sulfur is equal to 32, so number of sulfur atoms will be equal to 254 0.05 divided by 32. So this will give you number of atoms. So you will get it here as approximately 7.9. So we will take it as, assume it as 8. So what will be the formula of the sulfur molecule? So formula will be equal to S8. So this is the answer. The formula of the sulfur molecule will be S8 because 8 molecules are combined together in a molecule. Students, I have made a mistake in speaking 1 or 2, 3 words because a number of times I speak solute, solvent, so there is a misspelling here. I have used here the word solvent for this W, but this is the weight of the solute and this is the weight of the solvent. And another mistake I have done is, please mind it, I have told Kb as the boiling point, but this is not the boiling point, this is the ebullioscopic constant. In Kb here is also constant and this is the boiling elevation and boiling point, and again here also I have spoken once that boiling point. So this is ebullioscopic constant and this del Tb is the boiling point and del Tb is the elevation in the boiling point. Thank you.